Okay, so hello everybody. Thanks for joining. Really excited to be here for .NET Conf. As we mentioned, my name is Steve Hook. I'm a principal architect with a consulting company called CEI, based out of Pittsburgh, Pennsylvania. So like we said, today I have a ton of content for health checks. I don't want to waste any time, so let's get right into it. Okay, so we'll cover kind of what a health check is and why we might want to use them. We'll jump into demos. I love demos. I want to be in there for most of the time. And we'll talk through a bunch of different scenarios. Once we cover those, then we'll get back to slides and we'll talk about some of my opinions on using health checks in production for quite some time. And so as we were just talking about, really, I think this became more of an important topic, as we heard in the keynote and many other sessions with .NET Aspire coming out with the new release, and using those health checks to really check to make sure that dependencies are there before you're calling them. This means that more developers are going to be using health checks as well. So I think that's great. And I will say at first glance, health checks, as we'll see, are very simple. You write 2 lines of code and you could get going and be successful. So you could stop right there at the 2 lines of code. So why do we talk about it, right? Well, it turns out that you can do a lot more with that. But there's a lot more going on under the hood that can get you into trouble, as I know firsthand. So I started doing health checks, and maybe an unconventional reason, I suppose. It was to help deployments go a bit more smoothly. So sometimes you end up handing over deployments to another team, and that team may not be familiar with the inner workings of an app after that's deployed. So I wanted to be able to give that team a tool to make sure that after an automated deployment, hey, things are looking good. I think other people, as we'll see, as I'll talk about, use it for different reasons, but those experiences changed my perspective on health checks, and that's why we're talking today. So like any new developer learning something new and having trouble with it, my initial reaction was, something like this. So I'll read this to you. Azure is randomly shutting down my app services. I need to go to YouTube and let people like, follow, and subscribe to my frustrations. Yeah, I think this fully demonstrates where we're at in a society on how we market social media, right? So market videos. And you'll see I added a little sparkle emoji here. As we've seen many times, that's going to be the universal symbol for AI. So maybe I'll get a few more clicks on that video as well. No, I didn't make that video, but it was really frustrating starting out. So when my health checks had problems, things would shut down, and then those outages are affecting availability and then the time to spin that back up. And I actually reached out to Microsoft support to really understand what was going on in some of these situations. And so after all of that information, I decided to read the documentation. I know, pretty old-fashioned, but it worked. And after really taking the time to understand all of what's happening, I became more aligned with what health checks could do for my app. So kind of translated into a different perspective that I had. And so I'll read this. So Azure's health check goals may differ from your expectations. Azure does a great job of explaining all the different ways that you can use the feature and what happens when health checks start failing. That's the key, right? And so then I can update my video with maybe something like this. Okay, it doesn't fit. Oh, well. I'll read that to you. Actually, health checks make a lot of sense if you take the time to read the documentation. Go figure. The feature is far more configurable than you might think. Sure, there are some tricky things to be aware of, but that's why we test. Okay, it doesn't have the same ring to it. It doesn't. But I'll keep the sparkle in there. Maybe we'll keep the clicks, right? All right, anyway, let's get into it and I'll show you what I'm talking about. Okay. All right, so here we are in .NET 9, Visual Studio, running .NET 9, very exciting. We'll see it on the Azure side as well, but we're going to do simple health check. I just want to show you some of the things that I have here in my program CS, just a few things to kind of speed things up. I have, well, not a whole lot. This web app does not do too much, but it has a database connection. It has some logging enabled. I have my HTTP client set up for some later examples, and then that's about it. So I would say that most people use health checks for regular checking of critical components in their app and reacting to some of those services that are down. So let's write the 2 lines of code that I was talking about earlier. So in our pipeline here, we'll say add health checks, right? Pretty straightforward. And then at the bottom here, we're going to use that. And so the use health checks piece of that is indicating, all right, I would like to have an endpoint to call my health check. I decided to use API/health check. And that's pretty much it. So when we call this endpoint, it will execute any checks that we have here. But this is a pretty simple check. So it's not doing a whole lot on this. So really what it's going to be doing is validating that the app is alive and can handle some requests as well. So let me hop over. Of course, it's going to switch over to a different one here. There we go. All right, so we can see I'm on localhost. We're running API/health check, and we can see that that's healthy. That's wonderful. Maybe not super exciting. Like I said, you could stop here if you wanted to, but let's take a look on Azure side. So I deployed this to Azure, and let's look at that piece of it. All right. So here we are, we're looking at the weather API, and we can see that, hey, look at that, .NET version 9. And that did change, 2 days ago? It was preview, now it's V9. So very exciting on that side. And to continue down here, if you're not familiar with where the health checks are, they're down in monitoring. We can go to health check right here. All right. And like any developer, we're going to skip any warnings that it might be telling us. We'll talk about that stuff later. So we'll just look at the rest of the page here. So we have a health check. We're going to enable that. We have the health probe path, which is just the path of what Azure is saying. What do you want me to call for these health checks? All right. And so we set that up. So we're going to tell it that's where I want you to go. And there's also some diagnostic information down here we're not going to cover. What I do want to talk about is the unhealthy instance removal. So this is saying it's a threshold for when that instance, if that instance is determined to be unhealthy for a certain amount of times, it's going to be removed from that load balancer. Right now on default configuration is 10 minutes. So imagine you have a 4 instance web app, and one of those instances starts reporting unhealthy. It will take 10 minutes until that's removed from load balancer, and then you'll just be left with the 3. And it could continue that process as well. There are configurations for this that you can set from environment variables as well. I don't have time to cover that, but just know that that does exist. All right, so let's jump up to instances on the tab. I just wanted to show this as well. This is the instances that you have running at the moment. Now I'm using a poor configuration here with 1 instance. We'll talk about the details of that in a moment, but just wanted to show you that you do have access to see that. You can restart the instance, and I am running a Windows app service here. And because of that, I can also view the processes within there. So that'll go dig into that instance, show you the processes, allow you to stop those instances or see what files they're using, all sorts of crazy stuff. So I have a bunch of screenshots that I've taken that demonstrate here's what this app looks like after you run it for a long time, so that we don't have to sit here for hours and hours and hours. So I have my first instance of that. This is just the basic health check and what it looks like when you take a look at application insights. Okay. And so we can see it was running from 8 to 9, and we had 60 total requests. And at the very bottom, super hard to see, I probably should have given you some margin there. It does show that it went to API health check and it returned to 200. And so yeah, we can see that it executed every single minute. All right. Okay, so that's great. We did some things. Let's talk about how you can take this a little bit further. All right, so you might be working with an application that relies on a database, and that's probably something that you want to health check. So let's see how to do that as well. So we have on add health checks, we can go down here and see the other checks that we have. So we can see add async check, add check with a type, and we have add SQL Server as well. So let me drop in a little bit of content there. All right. And so from this side, really what we're saying, all we have to say is what's my database connection string to that? And then tags are something that, well, we won't have time to cover that full solution, that full feature, but tags are used in some predicate binding there. So you're actually able to create different endpoints if you wanted to do that, different endpoints that might check database or might check external components. And you can filter all of that based on tags as well. All right, so let's go ahead and see what happens with this SQL Server example. All right, there we go. And so now we can see that we're showing unhealthy. And so nice to see a different status. Not everything is rainbows and unicorns, right? So it is unhealthy in this situation. And that's just because my database connection string is not very good. So I wanted to be able to show you an unhealthy example as well. All right, so extending this a bit further, there are a few more configurations within here that I want to cover. Some of them can get you into trouble. So the next one is this health query. So we can see it's a little tiny. I'll make it bigger here in a moment. We can see that the default health query is select 1. All right, so if we do, I'll just drop this down here so that we can see that. Right, so it does allow you to change the health query. This is a really great query for that because it is just a ping. Does this exist? Is the connection string looking okay? And your first reaction might be, oh, this is great. Now I can change this to select star from orders where my order ID equals my test ID. Yeah, don't do that. It is intended to be a ping. And so that's where you can start to get into some trouble. So let's take a look at what this example might look like if we're failing for 1 hour. Okay. All right, so I have a screenshot for that one. And here we go. We'll drop this in. Okay. So we kind of know what to expect from this, right? Because we talked about the load balancer side of that. So here we are running for about an hour. And we can see at the bottom, well, maybe if you can see that, I'll explain that. So it's hitting our health check and it's returning 503s. So it is failing. It is showing unhealthy. And after that 10 minutes of time, it's going to remove that from the load balancer. Well, it actually didn't because I was running one instance in this example. If I were running 2 or 4, it would remove that. But after an hour, something happened. Something terrible happened. What it did was it removed that instance. And so you might not be expecting that. So let's go back, kind of imagining that developer of what happened. What did I do wrong in health checks, right? Oh, there's this banner. Didn't we skip this banner before? So this banner has been updated very recently to be so much more informative. So let me just read a section of this. It says, your site has a single instance, which will not be removed if it becomes unhealthy. We saw that. However, after 1 hour of continuous unhealthy pings, the instance will be replaced. This message used to say, hey, you're running one instance. You should probably run more if you want to get the most out of health checks. And that was it. Okay, maybe I'm paraphrasing there. The documentation was far better than that, but it pretty much said that. So we can actually see that happening here, if I take a look at this screenshot, when it was failing. So at the top here, I have a screenshot of when it was failing, but not into the hour. And so we had one instance. And at the bottom, this is after it failed and after it restarted that instance. And we can see, as not restarted, but re-instanced it. And so we can see that that changed, right? So that might be a little bit unexpected for you if you're new to this. And so it had me realizing that the mentality that I should have for health checks, and hopefully this is a takeaway for you, is only create health checks that return unhealthy if you feel that restarting the app will correct that problem. And then as a developer, you start to think, well, what scenario is that? Because, you know, our code is amazing and restarting an app is not going to change that. Or perhaps you should think it's a database problem. Restarting my app isn't really going to fix that. And so those are some of the questions that you need to start asking yourself. But I will say the turn it off and back on again mentality works more times than I think we'd like to admit. So going back to code, unless your app has full reliance in this database, you probably shouldn't be saying that your app is unhealthy just because it can't connect to this database. So instead of saying unhealthy, we can say something else. All right, so we also have a failure status, and this is saying, when this thing can't connect, what should I say? Now, we probably don't want to say that it's healthy, but we don't want to say it's unhealthy. So we have degraded here. So degraded, kind of an interesting scenario there, is saying, let's report back that things are good, but also have the capability of logging, of tracing, and handling a problem a little bit more delicately, not to the point where it's going to remove this app from a load balancer and all this crazy stuff, right? And so I want to show an example as what you would expect here for a health check that ran for 2 hours. So from 1 to 3, ran for 2 hours, returning degraded. Now it's doing a little bit of sampling here. It was 120 requests there, doing one every minute. And at the bottom here, this was returning degraded, but it is returning at 200. Now what I should have done here is actually include the events for trace as well, because trace is telling you that it was degraded. It'll actually give you a line item within there. And so that means that you can act on that. There's all sorts of information you can do, from creating dashboards for this to creating alerts for this. Some of those alerts myself to know, okay, something, if my health check even goes down, 1% in terms of how available it is, I can get an alert for that. I have a dashboard for all the different health checks. So lots of info, for that sort of stuff. Okay. Now I want to jump into external checks. So an external check, maybe also known as an API check or a dependency check. So there could be times that your application relies on certain endpoints or even external resources to ensure that it's healthy. And so these are typically more involved, because when I started out using these quite some time ago, that was sort of the path that I took, is that I created external checks. I went straight to that as a developer. Okay, I'm going to write code to say what is involved for my application to say that it's working. And so the original value for me was making sure that tokens were up to date. So I was doing larger operations to say, let me go get a token and then let me go make a call into an API. And that can kind of be some more complicated work. So let's look and see how we do that. We talked about a couple others here on this add check. We also talked about this add check with a type. So really that's what we're going to do here. So you do have the capability of doing some inline checks here, and just getting an inline function to do whatever you need to do. I would say in the real world, that probably doesn't happen too often. You're probably going to be looking at a specific class to do some of that work. So now we're saying, in addition to that normal health check that we had to state, does it exist? In addition to the SQL Server test to make sure that the database exists, we're also going to execute this code. And you can give it a name, you can give it tags like we talked about before. And so let's take a look at this class. I tried to make this a little bit more real world. So if you're a fan of the HTTP Client Factory, we're going to pull that in, which means, hey, you could do dependency injection here. It is the same thing, right? So bringing that in, we have our HTTP Client Factory. And at the bottom here, we're implementing this check health async, which I guess I should mention that does come from the iHealth check. That's how it knows. All right. And so from here, I'm getting an HTTP client, and then I'm going to do a response. And I don't really do much with the response, but let's go hit .NET Conf. You would probably hit an endpoint here that did whatever you needed to do, and return healthy if it's good, or unhealthy if it's not. Yeah, probably not. So we should maybe change that. Whoops. So we should probably change that to be degraded, right? Because we've learned from that. So that's great. And I will say that you can take this too far, just like I did. So for example, some of the things that you might see, if you are a user of the HTTP Client Factory, you'll also see that I'm passing in a named client. That named client might be the same name that I'm using throughout the rest of the app, which means it probably has some resiliency as well. It could be doing some level of retries, and that can be a big problem. Ask me how I know. So you might have some retries that will kind of exponentially retry, and in some cases maybe even go past that minute that you had in that health check, and now you're still retrying last minute's health check while you have another health check running, and it's just going to cascade and cascade. So not in a good spot there. So yeah, really from my perspective in using this, that was my issue, is health checks doing too much. You also have that balance of, are you checking other people's code here to say that your app is unhealthy because of that code? You kind of look at that a bit and look within there. Also running one instance. You don't want to be running one instance. It will restart that instance because that's all it has. So it's not going to remove from load balancer, but it will bring your app down if you have that one. And then so really ways to adapt to that. Removing those external checks when you don't need them. Go back to simple checks. Think about unhealthy versus degraded. And then for me, another one was not using custom queries within your SQL as well. All right. So I want to hop over to slides as I have just a minute or so to wrap some of that up. So let's go over here. All right, so I did a couple lessons learned on here. I tried to identify a few points that, from my perspective, what was really useful, and then I have a couple takeaways for you as well. So from the infrastructure side, do make sure that your app service plan is scaled to more than one instance to benefit from the health checks, right? Otherwise, you could be bringing them down. And again, we've covered these. They're just kind of takeaways for you as well. So the load balancing, we mentioned that after 10 failed checks, which is configurable, you're going to go to load balancer. The big one there of after 1 hour of failed checks, you may be re-provisioned. Now there are configurations to say you should have 50% of your instances or 75% of your instances available, and it won't remove those. The next one here is the hit home point that I mentioned of only creating health checks that return unhealthy if you think that restarting that app is going to make a difference. And again, that is a hard choice to determine, especially from a developer's perspective of how can an app restart help that. So create your checks wisely there, and then really understand what degraded is. And so knowing that if it's not critical to your overall app, if your app can still function in some way, you probably shouldn't bring the site down, essentially, in a check if you can do other things within there. It's far better to use any sort of logging, dashboarding, reporting to figure out what the problem is and address it. And then we just mentioned the do not retry as well. All right. So wrapping it up, I did just put a couple things on here, maybe not expected that we're reading through everything. I'll just touch on a couple here. We mentioned that the basic health checks only verify that your app is ready to go. We touched or maybe hinted a little bit about the difference between a .NET health check and an Azure health check. Right? Azure can point to any old endpoint for that check as long as it's returning the right things. .NET has features to do some of these health checks in a much more organized way. So we're kind of pairing the two there as well. Some of the more advanced things we didn't get to cover. There's a whole world out there for custom publishers. I recommend that you read up on the docs for that, on sort of a way to control the reporting of what happens on some of those. And then I missed this initially too, was app service slots do health checks too. So when you're looking through your logs and wondering, why am I getting all these health checks? The slots do those too. All right, so that's all the time that we have today. I do encourage you to go check out .NET 9, just as I have. And I thank you for your time and look forward to myself actually reviewing the rest of .NET Conf together.